All right. Let's get into this. Region between curves, area between curves. There's not too much to this. Okay, I lied. The concepts aren't bad. But maybe the algebra might get a little nutty. Even on this first one. So let's see. Oops. You can see I've already made a video and then realized, the first problem I did was way too tough. So I need to do something simpler. So the area of a region between two curves. So suppose you got two functions, f and g, and they're continuous. With one function just being bigger than or equal to the other one, so f greater than or equal to g, on some close interval from a to b. So it's continuous. One function is bigger than or equal to f than g. Then the area of the region bounded by the graphs of f and g on the closed interval from a to b is the top function minus the bottom function. Take the integral of that from a to b, and that'll get you the area. So let's just see, like, hey, we got two functions here. We have the square root function from 0 to 4. And then we have the line y equals 1/2 x from 0 to 4, and then they connect. And we want to find this area between the curves. So we look at this and we're like, well, the top function, the one I'm going to call f, and say, well, f of x is just equal to the square root of x. And then our bottom function, we call that g of x, is just equal to 1/2 x. So that's saying, all right, cool. We found their intersections. It's already given to us in this problem. Typically, you have to go find your own intersections. Got to do algebra, so the algebra does not go away. It only amplifies. Let's see what we do. So let's see if we can't find that area. So that area is going to be equal to the integral from our a is equal to 0 on up to 4. And our top function, our f of x, and then we need to subtract out our bottom function, our g of x, on this interval. But as we said, we already know our f of x. That's the square root of x. Sorry, I'm just going to write this x to the 1/2. Nobody wants to write it like that. And then our g of x, well, there's our 1/2 x. Cool. Now we're just doing a simple power rule. There's not much to this. Very straightforward. Very straightforward. So we take our antiderivative. So we're going to add 1 to our exponent and then multiply by its reciprocal. Now we're going to add 1 to this exponent squared, and we got to divide by that number, so we end up with 1/4 x squared, and we go from 0 to 4. Oh, zeros are the freaking best. Zeros are the best. Love them. So we get 2/3 of something to the 3/2 power minus 1/4 something squared, and that's going to be for our upper bound with the 4 popped into it. And now we have to subtract out 0. Just jump in that step. Now, do you remember? Do you remember how to evaluate this? Because you can't just leave it as 4 to the 3/2 power. That's some straight nonsense. Yeah. So we have 2/3 times 2 squared to the 3/2 power minus 1/4 times 16. The 2's cancel. 2 times 3/2 is just 3. So we end up with 2/3 times 2 cubed, which is 8, minus 4. So what do we got? 16/3 minus 4. Minus 4. Minus 4. For an answer of 4/3. That's pretty mellow. That's about as mellow as these frickin' problems can get. They don't get much simpler than that. So I'm just going to stop this one early, and then we can get into one that might take a little bit more time, a little bit more thought, have to know what's up, no graph given. Okay, maybe I lie. Maybe I'll give you a graph. And then we go through and we'll get it done. All right. See you in the next one.